Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It's our 8th lesson on a given Form 2 mathematics topic called equations of a straight line. So we are looking at our 6th example, which is a past Kcse question tested in 2022, paper 1 question number 19. It reads that a triangle ABC is right angled at point A. Therefore, I'll draw a triangle ABC which has the 90 or which is right angled at a given point A. Now, assuming that this is my triangle ABC, so it is right angled at this particular point, which is the point A. Then, of course, this will be point B. Then we also have another point C. Then I'm told that the vertices of the triangle are, we have A, which is 1, -2. So this point is 1, then comma, -2. Then I'm also given the coordinates for point B, which is 5, then comma 4. Then I'm told that point C has the coordinates of M, then comma N. Then I'm told that the equation of the line BC is, so this line has the equation of 5y minus x is equals to positive 15. So in part A, Roman 1 of the question, I'm being told to determine the equation of the line AC in the form AX plus BY plus C is equals to 0, where A, B, and C are integers. Now, for us to get the equation of a straight line, we need to have at least one coordinate along that particular line, and of course the gradient. So of course, AC, I'm already given the coordinate for point A. So what I need to find is the gradient of the line AC. Because I'm told that the triangle is right angled at point A, it simply means that the line AB and AC are actually perpendicular to each other. Therefore, let me start by finding the gradient of the line AB. So of course, the gradient will be given by change in y over change in x, which is y2 minus y1, then of course divided by x2, then minus x1. So I'll let this coordinate to be x1, then this one to be y1, then this to be x2, then of course this to be y2. So if I substitute, the gradient of AB will be given by, so I'll have 4, which is y2, minus y1 is -2, then divided by my x2 is actually positive 5, then minus my x1 is actually positive 1. Remember, here we are having minus because we are having 4, which is y2, then minus my y1 is -2. So this will give me 4 minus will give me 4, then of course plus 2, because minus times minus gives you a plus, divided by 5 minus 1. Let me separate my working with this particular straight line here. So I'm going to end up with the following. So the gradient of the line AB will be given by 4 plus 2, I'll get a positive 6. Then divided by 5 minus 1, I'll get a positive 4. Now when we simplify this, we'll end up with by 2, 2 times, by 2, 3. So the gradient will actually be 3 over 2. So that is the gradient for the line AB. Now, clearly we can see that the line AB is perpendicular to the line AC. Therefore, I'll say that since the line AB, is perpendicular to the line AC, it follows that M1 multiplied by M2 should give me -1. So the product of the gradients of two perpendicular lines should always give you a -1. Now, if I let the line AB to have the gradient of M1, then the line AC to have the gradient of M2. Therefore, if I substitute, my M1 will be 3 over 2. So I'll have 3 over 2 multiplied by M2 to give me -1. So I'll multiply both sides by the reciprocal of 3 over 2, which is actually 2 over 3. I also multiply this side with 2 over 3, so that these ones will cancel out. So it means that M2 will actually be given by -2 over 3. Now remember, M2, this is simply the gradient of the line AC. So the gradient of the line AC, which is M2, is actually equal to negative 2 over 3. Now, because we now have the gradient of the line AC, then of course we have one of the points, which is actually point A. We can easily get the equation of the line AC. Now I have the gradient. We know that gradient should be given by changing y by changing x, which is y2 minus y1 divided by x2, then minus x1. So I'll take the point on the line AC. I'm given the point A. So I have point A, which has the coordinates of 1, then comma negative 2. Then I'll also pick a general point x, y, so that this will be my x1, then this to be y1, then this will be x2, then of course y2. Now when I substitute, I'll end up with the gradient of the line AC is actually M2, which is actually negative 2 over 3. So this should be equal to my y2 will actually be y. So this is y, then minus my y1 is negative 2. So minus negative 2, then divided by my x2 is actually x, then minus my x1 is actually 1. So this is the same as saying negative 2 over 3 equal to, so of course this will be y, negative negative will give us a positive 2, then divided by x minus 1. Now on cross multiplication, we'll end up with negative 2 into x minus 1. So this one will multiply with negative 2, then 3 will multiply with that. Being equal to 3, then of course into brackets, I'll end up with y, then of course plus 2. Now if I open brackets, I'll end up with negative 2x, then negative negative will give me a positive 2, being equal to 3y, then of course plus 3 by 2, I'll get a positive 6. Therefore, I'll take 6 towards the left hand side, so that I end up with negative 2x. Of course, 2 minus 6, I'll end up with a negative 4, being equal to 3y. Now, they wanted the equation in the form ax plus by plus c is equals to 0. Therefore, I'll take all these values towards the right hand side. I also take this towards the right hand side. So if I do that, I'm going to end up with the following. Let me create another line here to separate my working. So alternatively, I can also rub at this particular area so that I can use it. So I'm going to end up with the following. So I'll just rearrange this particular equation. So this is what I'm going to get. So I'll end up with 3y. Then when negative 2x crosses equal sign, it becomes a positive 2x. Then of course 4 will become a positive 4. On the other side, I'll still remain with 0. So this equation can be rearranged because they want my equation in the form ax plus by plus c is equals to 0. Therefore, I'll start with the x. So this will be 2x, then plus, I'll follow it with y, plus 3y. Then I'll follow it with c, which is the constant without the variable, being equal to 0. Therefore, this is the equation in the form ax plus by plus c is equals to 0. Then I'll move to Roman 2 of the question, whereby I'm being told to determine the coordinates of the point C. Now, to get the coordinate of point C, we'll check the point of intersection of our triangle. Let me redraw the triangle here. So we had point A, point B, and also the point C. Now, if we look at our point C, remember this was point A, whose coordinates were, we had 1, negative 2. Then we also had a point B here, which had the coordinates of 5, 4. Then we had the point C here, which had the coordinates of m, n. Remember, we are given the equation of this line, which was 5y minus x is equals to positive 15. Now remember, we have also found the equation of the line AC. The equation is 2x plus 3y plus 4 is equals to 0. So the equation of this one is 2x plus, so this is 2x, then of course plus 3y, 2x plus 3y plus 3y, then plus 4 is equals to 0. So plus 4, this was actually equal to 0. Now we need to find the coordinates of the point C. Now clearly we can see that at point C, this particular line, the line BC and the line AC are actually intersecting at point C. Therefore, we'll say that at the point C, the equations, that is at the point C, we'll talk of 5y minus x is equals to 15, and the other equation which we have found to be 2x, then of course plus 3y plus 4 is equals to 0 are simultaneous. At that particular point, these two particular equations are simultaneous. Now, simultaneous simply means that we can solve them by either using elimination or a substitution method. So let me use elimination method. So I'm going to rearrange my equations. So the first equation is this one here. I can rearrange it as 2x, then of course plus 3y. Then I'll take 4 to the other side, so that when it crosses the equal sign, it becomes a negative 4 is equals to negative 4. I'll also rearrange this in the same format. So I'll start with negative x, then plus 5y, then is equal to positive 15. So to solve this, I'll multiply. I want to eliminate the x. Therefore, to achieve that, remember here the coefficient is negative 1. So I'll multiply the first equation by negative 1 and the second equation by 2. So that I'll end up having the following. So negative 1 times 2x, I'll get negative 2x. Then negative 1 by 3y, I'll get negative 3y being equal to negative 1 by negative 4, I'll get a positive 4. Then 2 times negative 1x, I'll get negative 2x. Then 2 by 5y, I'll get positive 5 by 2, I'll get 10. So positive 10y being equal to, of course, 15 by 2, I'll get positive 30. Therefore, I'll subtract the two equations so that I can eliminate x. Negative 2x minus 2x is the same as saying negative 2x minus will be plus. So if you have negative 2x minus 2x, negative will give you plus. Negative 2x plus 2x will give you 0. Therefore, the x will get eliminated. So I'll have 0, then negative 3y, then minus positive 10y. This is the same as saying negative 3y, then of course minus 10y, which will give us negative 13y being equal to, then 4 minus 30, I'll get a negative 26. So negative 26. So this will give me the following. So I'm remaining with negative 13. So this is negative 13y is equals to negative 26. If I divide through by negative 13 by negative 13, I'll end up with y being equal to a positive 2. Then I'll say substituting y is equals to 2 in, let me substitute in the first equation. I'm substituting in 5y minus x is equals to 15. I'll end up with the following. So I'll end up getting 5 into y. Of course, my y is positive 2. Then minus x is equals to 15. So this will give me 10 minus x is equals to 15, which can be rearranged as x is equals to 10, then minus 15. Then let me separate my working with this particular straight line here. So I'll end up getting the following. So 10 minus 15, I'll get negative 5 being equal to x. Therefore, the coordinate for point C, which is simply x comma y, will give me, so I'll have C is equals to, my x is negative 5, then comma, my y, of course, was positive 2. So these are the coordinates for the point C. So point C is having the coordinates of negative 5, then comma, positive 2. Then we check part B of the question, whereby we are being told that a line passes through the point A and is parallel to the line BC. Determine the x-intercept of that particular line. So let me sketch again the same triangle that I had here. That is the triangle ABC. So we had the point A here. Then of course we had this particular line that is BC. So this was our point A, which had the coordinates of 1, comma, negative 2. Then we had a point B here. Then of course we also had a point C here. Now I'm being told that, of course this was the 90. I'm being told that a line passes through the point A and is parallel to line BC. So we have a line which is parallel to this particular line BC, and this particular line is passing through the point A. So assuming this is the line passing through the point A and is parallel to BC. So let this be my line which is parallel to BC. So roughly this line is parallel to BC and is passing through the point A. Now we know that for any given pairs of parallel lines, we'll always have equal gradients. Therefore, I'll find the gradient of line BC. Remember, for BC, we were given the equation as 5y minus x was equal to 15. Therefore, I'll start by finding the gradient of the line BC. So from 5y minus x is equals to 15, I'll arrange it in the general form, which is y is equals mx plus c. So I'll have 5y being equal to a positive x, then of course plus 15. I'll divide through by 5 over 5, then of course over 5. So 5 and 5 will cancel out. So I'll end up with y being equal to, this is same as saying 1 over 5 x, then of course plus 15 over 5, I'll get a positive 3. So this one is in the form y is equals to mx, then of course plus c. So clearly the gradient is the value of m. Therefore, the gradient of the line BC is actually 1 over 5. Now, because I'm told that the two lines are parallel to each other, I'll simply say that the gradient of a line of the line parallel to BC, parallel to the line BC, must be equal to the gradient of the line BC, of course, which is equals to 1 over 5. We know that parallel lines have equal gradients. Therefore, the gradient of this particular line is also 1 over 5, since it is parallel to BC. Now, I have, we know that the gradient must give us change in y over change in x, which is y2 minus y1 over x2 minus x1. So I have this particular point. This line is passing through the point A, which has the coordinates of 1 and negative 2. Then, of course, I'll also pick a general point, xy, on this particular line. Let's say this was the point xy on the line. So this is x1, then, of course, y1, then this is x2, y2. Then, so if I substitute, the gradient is 1 over 5, so that I get the equation of that particular line. So the gradient is 1 over 5, should give me y2, of course, is y minus y1 is actually a negative 2, so I'll have minus 2 divided by x2 is actually x, then minus x1 is actually a positive 1. So this is the same as saying 1 over 5 is equal to y minus minus will give me a positive 2, then divided by x minus 1. Then if I perform cross multiplication, this one will multiply with that. Then of course 5 will multiply with the other coordinates. So this is going to give me the following. So I'll have 1 into bracket x minus 1 being equal to 5 into bracket y, then of course plus 2. So this will be x, then minus 1 being equal to 5y, then of course plus 5 by 2, I'll get a positive 10. So if I take this towards the left hand side, I'll end up with x, then of course negative 1 minus 10 will give me negative 11 being equal to 5y. Therefore the equation is 5y of course is equals to x minus 11. So this is the equation of the line which is parallel to the line BC. But they wanted us to get the x-intercept. Now we know that at the x-intercept, the coordinate of y is always equal to 0. Therefore, I'll substitute in this particular equation. So I'll have 5 into the coordinate of y is 0 should be equal to x minus 11. So this will give me 0 is equals to x minus 11, which can be written as x is equals to 0, then of course plus 11. Therefore, it means that x is equals to 11. Therefore, this is what we are calling the x-intercept. So this is the x-intercept, of this particular line. So this one simply means that if we were to plot this particular line on a given Cartesian plane, this is how the line will actually appear. So this will be the line. If this is the x-axis, then of course this is our y-axis. It means that this particular point will cut the x-axis at point 11. Therefore, this particular line will cut through the x-axis at the point 11. So this will be at the point 11. Now, if you are asked to find the coordinates through which the line will cut the x-axis, the coordinate will just be 11, 0. But actually, the x-intercept is actually x is equals to 11. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscribe button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kcse Tuition Academy. Thank you very much.